Thank you everyone for attending and to the CHR committee for facilitating today's seminar. It is a pleasure to welcome and introduce Professor Simonovich to the Riddell Faculty of Environment, Earth and Resources and to the first speaker of the seminar series. Dr. Simonovich is a professor in the Department of Civil and Environmental Engineering at the University of Western Ontario at the Institute for Catastrophic Loss Reduction. With expertise in system dynamics and its application to watershed management, climate change, risk and resilience. A fellow of the Canadian Academy of Engineering and the author of numerous books, including Floods in a Changing Climate and a System Approach to Management of Disasters, and over 450 articles, Professor Simonovich has contributed to both the private and public sectors in tool and diagnostic development, amongst which includes diagnostics for quantitative resilience, and as we will witness in today's talk, developing rainfall intensity, duration, frequency curves for future climate scenarios, diagnostics relevant to planning, design, and operation of municipal water infrastructure, and relevant to projects both at the Universities of Manitoba, Winnipeg, and as Greg has mentioned, the Lake Winnipeg watershed. Please join me in welcoming Professor Simonovich to the faculty.
Thank you very much. Thank you very much. It's a great pleasure being back. I always consider Winnipeg my home, definitely first home in Canada, and still have family here. So for me, it's any opportunity to be back, greatly appreciated. So thank you, Jennifer, for arranging this. I would like to share with you today a little bit of work that we have done. Sorry, under the support of the Canadian Water Network, in trying to disseminate some knowledge related to impacts of climate change on management of water resources. So the project that was supported by the Canadian Water Network was focused on deriving the rainfall intensity, duration, frequency curves, very commonly used tools by engineers, planners, and water resources managers under the future climate scenarios. This work and the project came about from my personal experience with very close collaboration with the City of London, where the University of Western Ontario is located. We did some work about 10, 12 years ago, trying to see how the IDF curves may be updated. So we were struggling and going through 2-3 different phases of developing the methodology, and finally succeeded, and the Insurance Bureau of Canada was very much interested to implement this technology used for the broader set of activities under the municipal risk assessment tool that they developed, and the methodology was implemented inside the tool. And at the same time, the Canadian Water Network came out with a request for proposals for the knowledge dissemination, and I started talking about this. We got a project with the support of about 20 different municipalities, because that is something that they really have a very high interest in. And the reason for that, for this audience, this is probably not necessary, but just point out that the increase in the global temperature is definitely affecting the frequency and intensity of extreme events. And municipalities are, where the rubber hits the road, because they deal on a daily basis, with floods and water supply issues, urban drainage issues, and so on. And all of them do require as input actually information on the precipitation. IDF as a tool is probably the most common tool used in everyday practice within each municipalities. Environment Canada is in our country responsible for collecting, processing, and generating the intensity, duration, frequency relationships that are being published. What you see on the right-hand side on top is one of the products of Environment Canada, where basically the historical information on precipitation is being used to come up with this probabilistic information on the precipitation depth as a function of duration and return period. The main problem with the tool and the product is that it's based on the historical information. And what we are now observing is, really serious change in the conditions around the country. I was just pointing out here the event from 2013, July 2013, then a very small 2-hour storm in Toronto generated 1.2 billion of damage, and that storm had a 140 millimeters precipitation that were compared to 100-year event, almost double the 100-year event. It's not only that this particular storm was, experienced in 2005. Toronto also experienced, very similar event, very large damage, and it seems that these events are coming more and more often. So that is, in a way, I think, if you look at the physics related to the change in the temperature, and it motivated kind of our idea to look at how can we possibly revisit the development of these tools and bring the climate change into the picture. This is the information about the project. This is a very special knowledge implementation program. So not development of the new knowledge, but implementation of the research knowledge that already exists to serve the kind of practical need. So we set as objectives for ourselves to develop the generalized methodology for updating the IDF curves under the climate change, and then implement that in a publicly accessible tool on the web. The project started in 2013, completed on March 1st this year, and from that point on, the tool is available for everyone on the web. Right now, we are, in October, we have a 473 registered users. The main surprise for me was that we developed this tool having municipalities in mind, and we developed the tool to assist with a very difficult, technical kind of issue, scientific issue. It made it very simple for the use. But when you look at the registered users, about 90% and maybe more are the consultants. So my feeling is that the tool is serving, consulting business to work for municipalities and probably generate some income. I would like % of that, but it's not working that way. Just to let you know that the whole process of developing the tool went in a very intense collaboration with the potential users. So from the definition of the problem, from the initial interest in our methodology by different municipalities, we really kind of defined the scope for the tool. And then when the project was initiated, we selected 2 municipalities to work very closely with. City of Toronto and Hamilton, like a very large and smaller municipality, participated from day one, working with us in developing the requirements for the tool, helping us actually bring the tool in the form that really serve the needs of the municipalities, and also provide the municipalities way of accessing, downloading, bringing all the information that they need for their studies outside of the tool. And then from this very close collaboration with 2 municipalities, when the tool was in a draft form, we had a very intensive kind of training program across the country. So we had meetings with municipalities in Eastern, Central, and western part of the country, where approximately 100 and, if I add all together, I think close to 200 actually municipalities participated, sending representatives to get familiar with the tool, provide us with some feedback, and also help us finalize the tool. In the same time, we also offered the webinars. So we had the 2 webinars, and this is the first time I realized how inefficient is the technology still. We hired a company to go through the webinar, and they limited the participation to 150 people, and I thought this will be probably more than enough. And we had such a huge interest that the whole system crashed during the first webinar. We were not able to kind of demonstrate in real time and so on. So you see, yeah, it was over 200 registered participants at one of them, and that first illustrated still very high interest for the tool, but also obviously the need for a different way of communicating with people in order to provide more information about it. Anyhow, through this process, we reached March 1st of this year, and the tool became public and is right now in use. Let me tell you a little bit more about the tool. My plan is to kind of give you a very quick background what the tool can do, and kind of walk you through a number of steps how the tool can be used. I was planning to also do the live demonstration because the tool is extremely friendly and easy to use, but somehow the internet is preventing me from downloading stuff on this computer. So I'll share with you you will have the information so you can try on your own. I also forgot to mention at the beginning that Canadian Water Network published a one-pager information about the tool, just the basic information with the access, and you are welcome to take a copy if you are interested. In order to build the tool, we still needed 2 major theoretical contributions to this kind of field in order to kind of standardize the procedure that can be used for any location. So 2 major contributions were made. One was in the area of basically selecting or assisting the user to select the global climate information. The tool is now equipped with all the available models and all RCPs, all the initial scenarios, and multiple runs that are available. So all the daily data is stored in the tool. However, that introduces a lot of confusion when the users, especially the users are not so much familiar with the process of kind of climate change modeling, have to choose which model, which scenario. Should I go with ensemble? Should I go with Canadian model, or should I use any other model? So what we have developed, first the tool provides the ability to work with any model you want. But we also provided something like a guidance for a particular location. We did a calculation of the skill score or the quality of the prediction of the future climate by all the models that are available within the tool. So the user has now access to each model, or all the models, ensemble combinations, as well as information on the skill score that kind of guides the user which particular model seems to be performing pretty well for the particular location. And the second important contribution was in the downscaling, since the development of the intensity, duration, frequency curves requires the sub-daily data, and most of the climate models are providing up to the daily temporal resolution. We needed a way to first bring this daily information to sub-daily data, and second, to also see how we can do that temporally, because the climate models are working on a grid basis, and we have interest to get observations and develop ideal curves for the particular locations, for the stations. So there are 2 methods. Both of them are kind of peer-reviewed and published. One was quantile regression skill score method, and another one is equidistant quantile matching algorithm that provides for the spatial and temporal downscaling. The first algorithm for basically deriving the skill score is looking into two things. We try to really make it relatively simple. The whole idea of attaching the skill score to models is a pretty disputable issue, and many people in the climate community are trying to not to do that, and there are lots of reasons. I can probably talk an hour just about that. But our intention here was to look at the distribution of the information and how the climate models perform in a way of kind of generating the distribution. And second one, to look at the kind of temporal bias over time or trend and see that basically GCMs or the climate models and the historical information provide something that that can be kind of matched. Based on these two sets of information, we were able to derive the skill score relationship, and that skill score relationship is now kind of calculated for each station, each model, each time you run the tool, and you have that information as piece of information to kind of guide you in the climate model. The second procedure for downscaling, temporal and spatial downscaling, was again utilizing the information from the global data and relatively easily, using some of the methods, bringing that to a station location. And on the temporal downscaling, we developed this quantile matching methods where two relationships were developed for the daily data. Again, looking the whole distribution, that was the objective. Daily data for the historical kind of period generated using the climate models, and the future data were related. And then the daily data or the historical were related to observed sub-daily data. So this is kind of taking care of the temporal downscaling, and this relationship is taking care of the spatial temporal, and this taking care of the spatial. And the very neat mathematical feature we arrived by, I think, just by following the idea, was that for the distribution of, or in the development of IDF curves, Environment Canada is recommending one of the distributions, Gandel distribution. And the Gandel is a distribution that, when related in this particular way, ends up with providing you relatively straightforward linear relationship equation. And that's a very effective kind of very effective outcome of the type of distribution that's recommended to be used for the IDFs. If you use different distribution, then these relationships become much more complex, nonlinear, and there will be probably more difficulties proceeding in this way. And this is how we implemented the tool. I'm sorry, my voice is... The tool is implemented in the form of the kind of decision support system with a very neat user interface, Google kind of map-based interface, where the user can go to around Canada, get the information, find out the stations, or if the need is, bring their own stations into the consideration. The second major part of the system is the model base, where all the statistical models, as well as the downscaling and skill score calculations, are stored. And the third one is a database where now, for all Environment Canada, we have 700 and so precipitation stations in Canada. All the data is stored in the tool. And all the climate models, for 22 climate models, for all daily data for all RCP scenarios, are also stored in the tool. So that allows us now relatively easy to go and select the location, implement the procedure, extract the necessary information, and generate the tool to present to the back to the user. These are the kind of basic information. The database is the repository of Environment Canada data and the climate data. User interface is providing very easy data manipulation and utilizing the background Google Maps technology. It provides for the visualization of the information. All the information is being provided in the form how is now being done by Environment Canada, tables, equations, as well as the kind of graphs. And the modeling or model base contains all the statistical analysis algorithms, Gumbel, and methods for fitting the distributions, GC and skill score calculation, and the IDF downscaling for updating algorithms that equals the equidistance downscaling. We have also one optimization model within the within tool because many of the municipalities are utilizing, instead of the graphs or tables of IDFs, utilizing the equations. So for the calculated IDFs for the particular duration and return period, we can, using the optimization tool, actually optimize the parameters of the equation and then provide the user also with the equation for the potential use. This is just to tell you, this is the kind of distribution of the Environment Canada stations, that there are some obviously issues if you look at the country, that we have much higher density of the observations and the longer term observations in the southern part, where most of the population is, and the northern parts are, kind of scatter is, as you can see, or the density is much lower, the observations are much shorter, observation periods are much shorter, and there obviously there are needs, in a kind of region which are kind of different from the needs of municipalities in this region. I will, towards the end of the presentation, I'm going to actually show you something that we have done after the tool was developed to possibly address some of the issues that may arise from this uneven distribution of the observation stations. Again, this is mostly for people who are not so familiar with the climate change work, but you guys are all familiar. This is just one of the explanations what are the current emission scenarios being incorporated. We are following obviously the IPCC recommendation for the models, as well as the representative concentration paths. The tool is built to provide direct calculation for 2.6, 4.5, and 8.5. And the reason we opted for that is that actually the RCP6 is interpolated even in the climate modeling data provided by most of the climate data. So it's possible to kind of derive that, but it will require some interpolation. This is the process of utilizing the tool. I am going to go to a couple of screens, so you're going to see that. Most of the things are kind of occurring in the background. And the user is exposed to the map where the location is selected. User has opportunity also to bring his own data, and then you have options of kind of producing the historical or reproducing the historical curves. So these curves will be completely the same as published by Environment Canada, or proceeding with development of the curves under the changing climate, where you have multiple options of selecting different climate inputs and so on. Just to kind of illustrate what is going on in the background, by kind of displaying the map and the spatial information, you can kind of read the information, the locations, the length of observation, display all this kind of at the map. You can zoom in, zoom out, identify exactly the station that you're interested, or identify the location that you're. When you click on the IDF curve development, then basically a number of steps are being performed by the tool. This is done very efficiently. You don't actually see that. By clicking, you almost immediately get the results out. Reading and organizing the data from the database, performing the kind of analysis of the data. So this is the first screening to be sure that you don't have some data that shouldn't be there. Then performing the traditional calculation using the Gumbel distribution, calculating the IDS, fitting the equation, and organizing data for the display. The information is provided in this kind of form. As you can see, this is the typical graphical form, but you have opportunity to print the tables as well as the equations. I think I have screens showing that. For the case of the for the case of future period or the climate, you have just to click on another menu, and basically the tool responds in a very similar way, providing you with additional information on the options for selecting the initial scenario as well as the climate model. In the background, you have now a number of things being done that I was talking about. We have a skill score algorithm calculating the skill score of each of the climate models. We have a downscaling algorithm that performs the spatial and temporal downscaling. This is all applied. That provides the data for the calculation, and then you use the statistical methods, the same as with the historical data, fitting the distribution, preparing the tables, graphs, optimizing the equations, and preparing that for the presentation to the user. So you see, but user sees only these screens and clicking on the menu options, and all these things are done in the background, and they're done, very efficiently. The reason why we opted to kind of present it this way was that it was very clearly pointed to me in many presentations and communications with municipalities that don't have expertise, they don't have enough technical expertise to kind of do that work. So we opted to kind of build the tool in a way that relatively, without the deeper expertise in all these areas, you can produce these relationships. I already mentioned that there are two ways of utilizing the tool. One is with Environment Canada stations or for Environment Canada stations, and another one is for stations that can be provided by the user. Many utilities, many organizations do collect data on their own. Manitoba Hydro is one that kind of maintains a number of stations in Manitoba of their interest, and they can use the same tool by bringing this information in and putting it through the process that tool is actually using in dealing with Environment Canada collected data. The creation of the station requires preliminary step where the user will need to kind of prepare the data in proper form, like the historical data that's stored by Environment Canada, and then use the way of inputting data into the tool, and then the kind of data is being treated in the same way as Environment Canada data. We kind of build a very neat features that users can share the data. The user can choose who to share the data with. Users can restrict modification of the data, or the users can allow groups to kind of work with the same data by either editing, updating, modifying, whatever information that they like. This is the way of accessing the tool. If you pick up this one pager, the address is there. If you don't pick it up, it's relative IDFCC UWO, University of Western Ontario. And the first screen you will be hit with is the screen that requires registration. We are only collecting this information so that we know who and how many users are there. As you see, it asks for the name, affiliation, and basically you create your own ID and password, so then you can use the tool. On your own. This will be after the registration. When you log in, this will be the kind of first screen that you've seen. You see, this is Canada. This kind of circles are indicating the numbers in the circles are indicating actually at this level of this resolution how many stations are actually in this region, and then you can kind of zoom in, and you will be seeing actually the stations at exactly their own locations. You have opportunity to do that in a graphical form by kind of clicking on the map and selecting the location for the station or selecting the station. You have opportunity to type in the name of the station, and you have also opportunity to search for the stations by selecting this menu item that provides you the list of all 700 and so stations that are available within the tool. When you select the station, the next screen provides the basic kind of information. So it is a ID number and the location of the station, the starting period of observation, the length, and this information is, very common and used. What I think it's important is that we are restricting the tool to basically process only the information of the stations that have more than 10 years observation data. My professors of meteorology will be probably pulling their hair off if you mention using only 10 years of data, but this is the kind of reality that we have a very large number of stations, especially in the northern areas with a very short observation periods. And this is definitely the minimum, and you have to realize that when you are estimating the 100-year return periods based on 10 years of data, you are introducing a lot of kind of uncertainty in that process. But that's the reality we are feeling. We are kind of dealing with always when we don't have sufficient observations. By selecting the station and selecting the option to do the historical IDF, this will be almost automatic output. The output is typical Environment Canada IDF table. You have a precipitation depth, you have the return. Depth is here, duration is here, and the return period is here. You can show the total precipitation depth, or you can show the intensity by switching between these two options. You can show the data also in the graphical form, and you can work with these graphs. There are a couple of menu items here that allow you to kind of select only one of them or multiple if you would like to do some kind of comparison. Allows you to export this information through Excel outside of the tool so that you can process the information further and prepare for your reports and things like that. So there are many kind of options that were basically pointed to us by the potential users as useful options for them to kind of take the information from the tool into their activities. And the third way of presenting is the equation that I pointed out. Many of the municipalities actually are using the equations and not the graphs, not the tables, where these parameters are optimized we are using one of the very effective new fancy optimization algorithms based on evolutionary programming in the background, and that particular algorithm very quickly comes up with the coefficients, and then these coefficients are basically the forming the equation that you can use. This is now the process how you proceed when you select the develop IDF curves under the changing climate conditions, and this is now a little bit different approach, or this is the initial screen where some decisions will need to be made by the users. The first is actually selection of the time period. The data stored in the database covers all climate models and all emission scenarios until 2100, and here you will be selecting, or the user will be selecting, the period for which the development of the curve is desired. This is the very important kind of part where the user should be selecting the climate model. And when we were talking to the potential users, this was pointed to us to be the most difficult part. Many of the engineers or the professionals working within the municipalities are not very familiar. They were asking questions, which model, which emission scenario, what is RCP 2.6 versus RCP 4.2, 4.5, and so on. So what we kind of provided here is a lot of flexibility, and then the tool also has the attached technical documentation as well as the user manual, where the user can kind of obtain additional information. But basically, here we have options to use anything that's available. You can use any model, any climate model. You can use any emission scenario. You can use all of them in a form of the ensemble. We developed the ensemble procedure, the calculation of the ensemble procedure in very similar ways IPCC is recommending. And in addition, each model selected will be automatically provided with a single number that will be that skill score measure. And the idea of the lower value of that skill score means the better representation or better quality of the model in output for that particular location. So through the kind of multiple uses or choices made of particular model, particular mission scenario, or ensemble of the models, the user's ability to actually generate a number of different IDF curves under the climate change, and then see the potential impact of selecting different models versus ensemble, or selecting one model versus another model, or selecting one emission scenario versus another emission scenario. So the idea of tool serving for kind of experimentation and possibly then deriving the recommendation which one to use is in the hands of the users. And the last kind of part of the input is, to identify what series will be used for the calculation, and we are recommending that always the complete series are kind of being used. Okay, this is just pointing out what I already mentioned, that we should suggest probably 20 years or longer periods. All the models are here, and the results will be presented. So the outcome is very similar as in the case of the historical information, except that you have now the additional kind of menu items here. So this is the product of the calculation. I think in this particular case, we were dealing with doing the calculation with the ensemble, and you have options to select various emission scenarios. You can plot, as you can see here, the IDF is plotted for the particular return period and particular duration for the different RCP scenarios together with the historical data. This is so-called the comparison graph that you can kind of generate, so you can immediately see the difference, what is happening with the extreme precipitation, or you can actually compare how different emission scenarios are affecting and what will be the difference that they may be resulting in. Let me just quickly show you how the new stations or user-generated data can be used, and I think that will wrap up my presentation. The new identifying the well to introduce the new station will bring you to the screen where you will be providing the information and identifying the kind of station you would like to create. You have options to do that directly from the map by selecting the location on the map and then saying that you would like to create a station of that location, or by going to the screen where you will put the name, ID, and then the latitude, longitude, and other information that's required. So this will be the kind of IP screen which will now identify the existence of the new station and put the station into the database, put on the map, and provide all the abilities for you to process the historical and future IDFs. The only step which is necessary before is by identifying the location to prepare the data in the format that the tool can accept, and the format is very much the same as the raw data format that Environment Canada is using, where you have the observations of different duration for the kind of periods of time. So it's relatively simple tables. We provided input ability directly from Excel, so you can import the Excel table into the tool, and that immediately converts the data into the format that all the other models will be using. From this point on, the tool will be performing all the checks and balances that it's doing with also official data, kind of checking the information, observing how long is the sequence, and then utilizing that in the calculation of the historical as well as the newly generated curves. So everything from that point on, when you import the information and when the information is checked, basically follows the same or is subject to the same procedure as the Environment Canada data. So this is it, and this is what the tool is doing. Tool is available to everyone. We are getting very positive feedback. quite often I'm getting, because my name is obviously on the introduction screen together with my email, and I'm getting the emails from people asking some questions of, how to use to the, emails. I think 4 days ago I got a huge, long email from Italy, and the tool is developed in Canada, and this is only dealing with the kind of Canadian stations. So what the colleague at the University of, or actually Polytechnic of Milan is doing is she is developing something like that for Italy. So she was very much interested in the kind of methodology that was kind of going to be behind and asking for some explanations. And so I was kind of a little bit surprised to see that even people outside of Canada are accessing the tool, learning what the tool can do, and then obviously trying to see if they can, if they can either use or utilize the methodology in their own locations. Now, I already mentioned one of the potential problems with the kind of stations and the density of the stations. So what we have done now, having the tool, we process all the available stations in Canada, all the available climate models, and then perform the kind of spatial interpolation between these, station locations. So this map is generated based on, in this particular case, I think 520 stations that have the length longer than 10 years. The process, this is a Canadian model, this is a RCP 4.5, and for one particular IDF curve, we generated spatially interpolated map that provides you with the precipitation that across the country. So you see, having something like this may help in the situations and the locations where the information is not available, so that the users can possibly identify, what will be the direction of change, what will be the potentially, kind of impact of different climates in different future periods. These maps are, I think, quite informative. You can do tons of stuff. We generated a lot of that from all the models, all the durations, return periods. We did also the comparative maps. Like this is the map that shows the difference between the historical and this particular climate model. So you can actually see now the calibration, what will be the difference, where is IDF going to, or precipitation going to be larger, where is the precipitation going to be smaller. So, the things we are talking of prairies and, experiencing some potential kind of reductions, and the coastal areas experiencing the huge kind of increase in the precipitations are now becoming nicely spatially visible. And at the end, I pushed the kind of envelope further, and we developed a kind of interactive access to these maps. So now, basically, you can move your mouse across the map and click on a particular location. You will have here the kind of coordinates of the location. You will have the information on the model, the scenario, the type of IDF, and the exact value of the precipitation. So this is all obtained from the station information by doing the spatial interpolation and developing these kind of maps. This is not available on the web, because with March 1st the project was completed, and that was not the plan. So we have done this work. All this information is available, could be very easily added to the website, tools website. But I think I will need to get some, financial support or get the interest of some of the agencies to kind of do that. In 2 weeks, I'm presenting the tool to Environment Canada, and I will be working very hard actually to try to convince them that they take some ownership in this work and possibly extend the tool by adding this spatial interpolation. The tool is supported. When you go into the tool, you will have access to the two technical documents. One is user's manual and one is a technical manual. User manual is just walking you through all the screens and steps that I tried to cover in the presentation, whereas the technical manual provides the details of the two methodologies we used for skill score calculation and the spatial and temporal downscaling. You can download them directly from the tool, within the tool, We also have a section with the frequently asked questions where we are kind of posting the questions and answers that may be of assistance to those who are just starting to use the tool. I already mentioned that the methodologies they are published, and we wanted to have this kind of peer review process. I do realize that what we have embedded in this tool is one way of doing downscaling, one way of calculating the skill score. There are other methods around, but we have very clearly described what the tool offers. There is also some publications on the engagement process, and they're being in the process of revisions and acceptance right now. For those of you who are more interested in the work of this nature, or what I'm doing generally through my graduate students in the Facility for Intelligent Decision Support, FITS, which is basically a computer modeling lab. Through my website, you can very easily access FITS, and then under the projects menu item, you have all the outcomes of our project in form of these blue books available. This is all free and downloadable, so it's much more detailed description of the research and research results than what the paper offers, with the limitation of 8 pages, printed pages or something like that. So feel free, and you can use the information that's available. I will stop here. I'll be very happy to answer any questions, comments. Thank you very much. Go ahead.
A couple of questions. One with regard to GCM data.
Yes.
In just the GCM data, are there bias corrections in it, or is it raw GCM?
These are raw GCM data. The process of bias correction comes through that downscaling method. So what the tool database provides is the information that the climate centers would provide. So if you communicate with the Canadian or UK or German center, you will obtain this daily data generated from their model for different RCPs. So that's what we stored in the database. Now the procedure that's implemented for spatial and temporal downscaling is actually following a very detailed process of how you downscale the global information to local level. This is where we are incorporating bias elimination. So this is all presented if you are interested in details, either paper or the technical manual.
And a more general, I think it's a more general question. If you live in Winnipeg, one of the reasons you'd be interested in the F curves would be to understand flooding.
Mm-hmm.
And most of that is coming from North Dakota and Minnesota. And you don't have stations there.
No.
So is it a difficult procedure to add in those stations? And secondly, obviously the GCM data extends globally.
Yeah.
So is it difficult to add a watershed worth of stations, or is that a major task?
No, it's not. It's the adding stations. You've seen. I described the process. Basically, you have the observations, bringing that table into the tool, and that's about it. Now, getting into different jurisdictions may raise other questions. USGS, for example, is not following the same procedure for the development of IDF curves. But if we are interested, or people in Winnipeg are interested to look at the Red River watershed, and then the stations in there, you can process them the same way how we process in the Canadian stations. So I don't think anything will be preventing, except that it will not be done automatically, that the user will need to bring the stations into the consideration. Also the limitation. Yeah, sorry, you actually pointed to a different point. The climate model data are downloaded for all the stations in Canada. So they're in the database right now. If you bring the station from outside of Canada, that will need to be also updated, or the climate model data will need to be imported for that location. You can run the model, but the method of spatial interpolation, like when you import your own station, the tool is looking for the Canadian stations which are closest, or stations which are closest to, and then does the spatial interpolation. So if you bring the station in Minnesota, it will identify probably 4 stations somewhere in Manitoba and try to interpolate from these 4 different stations. We were giving the short seminar in Taiwan, and we were in Taipei, and one of the attendees typed the station in Taipei, and the tool continued calculations by interpolating with the 4 station closest stations in Canada.
You had an assumption stated early on about stationarity. And the fundamental assumption is that we are in a stable situation. Can you comment on the adaptability of the model or the ability to export the data for localized spreadsheet manipulation or other kinds of sensitivity analysis? How do you deal with the likelihood that stationary assumptions cannot continue?
This we already dealt with. That method, the quantile matching method that we use for the spatial and temporal downscaling, is actually the method that is being developed in order to address the fact that we are dealing with a non-stationary time series. The relationship that I described between the distributions of the kind of future precipitation and distribution of the precipitation for the historical period derived using the models and the data for the subdaily. That process is actually a process that develops the relationships between the future and now, that is not taking the kind of historical information and continuing that as a projection for the future. So this is already response to this fact that we are probably in the kind of non-stationary state. The second question you asked is from the output tables, graphs, or equations, you have an additional menu that you can take any information outside. And we talked a lot about the format. If you would like to, for example, get all the simulations of the climate for a long period of time, there could be lots of data also too. But users insisted that they have access to that data. So we are providing in a small menu above, you see the number of lines above the graph, opportunity to export all this information that goes out, usually in the Excel form tables, and then the users can do and perform any kind of analysis they want. We are very much encouraging running the tool for various climate models and various combinations like ensemble, as well as some of the models that you may have preferences to, or models selected by the skill score, because that gives you a little bit better understanding of the uncertainty that comes from the fact that different climate models today are producing different results. Different emission scenarios will produce the different precipitation patterns and intensities, and that is important, I think, in decision making. When you talk to municipalities, engineers are so, they want to push for a single number. Tell me what is going to be in 2025, and that there is no design. The moment you mention uncertainty range, that's really difficult to bring into decision making process. And I'm permanently, when I'm making these presentations, I'm permanently talking, you have opportunity now to very fast actually generate multiple results and learn about that uncertainty, get some sense. And I wanted to run the Winnipeg, with you here to see, for example, what is that range. It's probably very different from London or any other location, and that's what I think is the benefit of having tool like that.
Just thinking about, you've got you're looking at extreme values of rainfall there,
Yeah.
but as a forest ecologist, I also think about, well, what is the interval between these rainfall events, and the fact that with intensification, there's some anticipation that soil moisture will reach low levels more frequently because there'll be longer intervals between those events. And I'm wondering if there's any thoughts, plans to, put it in the mirror and look at the drought interval.
We are doing, my group is doing a lot of work but not in this one. This is a very specific tool for a very specific product. IDF is something that municipalities need, use, and I think it's very important that they get the climate change into that. this is not a trivial question. Even if you propose to city council use of the IDF under particular scenario in the future, you may end up in a very costly change to design of pipes or bridges or roads or other infrastructure. This is a different question, and I would suggest that you maybe go to our website and you will see there were 2-3 projects where we were assessing the impacts of climate change on the watershed scale. And we worked in 2 watersheds in the southwestern Ontario, Thames River, where the city of London is, and nearby Grand River. So in these 2 studies, and the second one is still actually going on with some extension on impacts of land use change on the climate change and so on. We actually did a very detailed analysis. We developed the downscaling tools and procedures, and then we assessed the impact on both low and high flows. So we utilized the climate data to come up with the precipitation and temperature. Then we processed with the hydrologic models to get the flows. When we got the flows and other information, we were able to do the kind of analysis of the impacts on the watershed. But that's a difference from what this tool is. This tool has a very clear kind of objectives.
I believe that you probably had a sensitivity analysis for the temporal downscaling, but you're using daily and from GCM downscale, the average already for hundreds and kilometers kind of to downscale to the spatially and then speed it out to hourly. But how the sensitivity was that kind of, if you do that with the one station which is apart from the next one, 100 kilometers, we have not many stations to validate, and you're kind of splitting out from the historical data to the climate kind of future, means you don't want to really stick with the kind of historical part of the
But we are spatially we are dealing with space that's predefined by the climate model tools. And the climate model data is provided basically in a gridded format. So what the tool does first, when you identify the location of interest of the station, it does the spatial kind of interpolation. So each location is utilizing the 4 points of the climate model data, which are closing the rectangle or space around the station. Inverse distance method is utilized, and you bring this information to the station. From that point on, we proceed with the methods that Dials can do.
The reason I'm asking is, you see the extreme events where they didn't have extreme events at all, and suddenly it happens. So spatially, it won't relate it to the historical information that you had it by the stations that is supposed to happen there, but it's not happening, and somewhere it's not happening there.
But the climate,
the intensity is also changing by the time you are
but that's what you're
examining to the hourly step, what is the average data. So the total daily data to a same kind of how do you it's gonna change kind of a lot, very sensitive to the idea of itself. How are you kind of disseminating the total daily data to how you are?
Yes, that's part of the downscaling, the original method that we kind of developed to downscale. So you are using the historical sub-daily data. You develop the relationship to daily historical period data generated by the particular model, and that gives you the relationship. So I can find out what will be the 2-hour, 5-year term period precipitation to a daily precipitation of 5-year term period. I have this relationship, and then I apply this relationship on the future. The same, or in the second part, is we relate now the historical daily data generated by the climate model to his future daily data generated by the climate model. That's the second relationship. So now I have these 2 different relationships which are combining the kind of historical.
Actually, I understand the process, but I'm just curious about how probably you did some sensitivity analysis, how accurately you could generate. I wanted to know whether you did something and how much of the accuracy you found out or something
Yeah, we do have, because the whole kind of downscale, that particular relationship provides you with the statistical aid. Actually, in the paper, we printed the errors and everything else. So that's, but you don't have the ability to deal, because the future didn't occur. I mean,
I know, the thing is, the climate change research is all about that, but you're targeting the municipality, the kind of the end user, but they, as you already mentioned, that when you go at the climate kind of change topic, to that the municipality, they put that, which one to use, even one data, but then you think, okay, we can use all data, all ensemble, or one, but then that will confuse them more, and then once they get the number, they will stick with the number.
You still don't have
That's a misunderstanding to them. Kind of, if you are a consultant,
I would be very hesitant to give the single number.
yeah, no.
I would be very
That's what they
hesitant.
need, because you have to decide
I know,
which
but-
design flow do I use.
But
Then I
that's-
need the idea first. before that one,
When we
right?
were working with the City of London before this tool, this is where we developed the methodology. I was asked the question all the time, can you kind of give us the single number? Can you give us the single number? And I said, I am very hesitant to give you the single number, or I can give you the single number, but you have to understand that there is a broad range of values around that number, and each value is equally likely as that number that I am kind of giving you. So we have to work, I think this is our responsibility as engineers, we have to work with the decision makers to convey that fact that our knowledge right now is at that level that it does to particular
So that's why, kind of, by running all those scenarios, you may have another stat to come up with and then decide which one should we go, but then it's process itself to go there is having already too many uncertainty involved in there, and then now you're using the output of it with all different kind of model with the scenario, and then now you have to make a decision, and how much of the uncertainty you will kind of increase at the end. Because that will change a lot.
Yeah,
and it
you
will
do
impact
have
a lot.
that. We have, if you generate, for different models, you will have the IDS for different models. So you have that range of uncertainty. That range can be presented together with the values. And that's, I don't think that it's our responsibility to make a decision, that still municipalities have to make decisions. What I'm suggesting is, attach some economic analysis now to this type of information. Okay? So what will be the consequence? City of London actually paid us $380,000 to bring now from this level information to risk to infrastructure. So we did a very detailed hydrologic and hydraulic analysis using the precipitation inputs from this. Then we did the damage analysis and the change of obviously flooding that may affect the City of London, and they gave us 11 types of infrastructure. We found out exactly the values. We developed the risk index and presented that. But this risk index can be different for different models and this is exactly how we did it. We presented the range of these maps so that they can see the difference, but still they have to make the decision. I don't think it's our
I'm not saying it's a bad tool, but saying that it's probably not proper for the municipality level, probably the consulting or some kind of who can give some better understanding with the expertise in the climate and other things altogether.
I tend to disagree. The municipalities are making decisions, and they are hiring consultants actually to do this work. Not to make decisions, to do the work, to do the development calculation. And I think the tool is actually able to cover that.
I think adding to the previous question, I'll say like if the tool is able to take all the models realization as ensembles, so we can suddenly have a range like over and up, and then we can go
Yeah, that's very easy. But that's a pretty lengthy discussion. The way how ensemble is created, the idea is to actually take a very low influence of the lower and upper bound of the values. You're kind of going with the median. By going with the median value among these models, you're hiding a lot of that uncertainty. So I'm much more open to show the values, show the level of uncertainty, and carry it into decision making that knowledge. And obviously the economics will decide, how much money we need to. we have to give, sorry.
That's a small question. How did you deal with missing data? Like these 600 or 700?
Okay, we are using the Environment Canada is already kind of dealing with that issue in the published information. We are using the kind of very much the same procedure. Missing data is, in the case of the longer historical series, basically ignored. In the case of the lower, then some kind of spatial temporal interpolation is being done in order to inbuild the data. But the procedure is not because even Environment Canada is not making that procedure public. So that procedure is not. So this will be the either if you are bringing your own data in, your responsibility. If you're using Environment Canada, it is already taken care of.
Environment Canada stations have 700, 800 standard stations.
Yeah.
For sure.
Yeah.
That is there and you deal with
Yeah, I told you that we can use only 500, because of the length.
city anyway. But if we bring any other data for say
Yeah,
station, then is there any approach or anything?
Not in the tool. Not in the tool. That will be the responsibility before you bring the data into the tool.
Can you provide about quality control in data? Because we order some data,
Nothing in the tool. The tool is doing just a basic screen of the data to see that you don't have some junk, very large numbers, or some negative classification or things like that. So that's a very standard set of screening that's being done, and we kind of try to avoid that on purpose because that's how the Environment is responsible for the data. I had a number of issues with them, especially when you're getting the sub-daily and sub-hourly information. These are different bucket data. They have two sets of data. You can buy so-called the raw data, or you can get the data, and you compare them, and they're different. And so we are opting for this official. That second set, what they provide, that's considered to be official. How they came from raw to that, I try to replicate that without success.
Corrections.
Yeah, there are some, but the corrections that they don't want to say how are they done, and that's something that we
you deal with snow gear, like on the precipitation they corrected already the data.
Okay, we already exceeded the time.
Thank you for
Okay,
being
ma'am.
there and coming out and talk. Appreciate it. Please join me in welcoming Professor Simonovich, and everyone's welcome as well to attend the lunch following to continue discussion and questions will be downstairs. Please join me again.
Thank you. Guys, if you're interested in this one pager, it's here, so whoever is interested.